We're looking at our level 2 simulation topic now. And so simulation is a form of probability, which is why you can see I've got some objects there that refer to it. So let's first of all have a look at what simulation is, be more specific about it. So here's a definition. It's the imitation of the operation of a real-world process or system over time. So the key thing is there that we're talking about something happening over time, and in this case we're trying to imitate a real-world process or system. Okay, so if I think, for example, our photocopier, an M8, if I want to know what the chance it is going to jam today, it's not something I could calculate theoretical. For example, a theoretical probability would be something like, I've got a coin, it has a head on one side and a tail on the other. If I toss that coin in the air, there is a 50% chance that I get a head and a 50% chance I get a tail. That's a theoretical probability. What we want to be able to do now is simulate something, because we don't actually know what the theoretical probability for our photocopier jamming is. Okay, so we can collect some data on it, we can come up with some estimates, and then we can run a simulation to come up with more precise estimates of the exact system we're looking at. So for example, if you have a look at, think about a flight simulator, and there's a little picture of a flight simulator. We don't put trainee pilots straight into an aircraft. We put them into a simulator, which is a big box which can move around, and it has all the controls inside, and they fly this box around. Okay, they're pretending it's the real thing, and that's essentially what we're doing with a simulation, is that we are pretending it's the real thing, and we're trying to come up with some reasonable answers. Okay, so that's what we'll do for our assessment. We're going to be given a situation. We then need to design a simulation for that. Then we have to run that simulation and evaluate how good it was. So, our first step is we're going to look for the problem. So there's two things in thinking about what are we trying to get to, what is the problem going to be, and there are two types. We can either investigate a probability. Okay, so what's the probability that the photocopier in M8 jams? Or we can find the average number of times. So that's looking at our measures of centre, our mean, median type stuff. So I might want to know, on average, how many times a day is that photocopier in M8 likely to jam, versus what is the probability that it's going to jam today. So those are the two, and I will give you that in your assessment. I will tell you explicitly which one of these two things you need to investigate, and when you come to your conclusion, that's what you need to, that's the question you need to answer. So for example, if I have 4 children, what's the probability that 3 of my children have blue eyes? And I'm telling you that the probability of any one child having blue eyes is 0.7. So what I now need to do is, I know the chance for one child, okay, and now I need to run a simulation to try and estimate what's the chance of 3 of the children having blue eyes. So I'm looking for a probability. Or I might ask the question, what's the average number of children that I have before I have 2 children in a row that have blue eyes? Okay, so I've still got the same probability of blue eyes being 0.7, but I'm trying to find a probability, not just the individual child having blue eyes, but the probability that 3 of these children, or what's the average number of children before I have 2 in a row. Okay, so that's our problem section.